Let's work on question 2 now. So we have to compute the definite integrals using the substitution rule. So it's very similar to what we did in the previous videos, but now the integral is definite, right? It has an interval. Okay, so let's see how that works out. We're going to use the same method. We have to find the relationship between what we're substituting and what is left in the integral. So the first step, let's see that. Now, intuitively, when we look at the relationship between x squared minus 1 and 2x, well, x squared minus 1 derivative is going to be 2x. So we already got something. Now let's do that. If we substitute u equals to x squared minus 1, what do we get? Well, we will have du derivative, right? Du derivative with respect to x equals to 2x. Now, with the cross multiplication, we can see that du is equal to 2x times dx. So we already have something. We got 2x times dx from here. We have it in the integral, so we're going to substitute. And we just said that x squared minus 1 is going to be u, so we will have e to the power of u. Okay, we got something but there's one thing to keep in mind when we solve definite integrals, right? The definite integrals. The idea is that the boundaries must also be changed, because the boundaries were given to us when the integral was in terms of x, but now the integral is gonna change with a variable of u, so meaning the boundaries must be adjusted for that as well. Let's see how that works out. Since we know that the new variable u is a function of x, then the boundaries can also be changed. So if x was equal to 0.1, because by the way, let's just understand why this is the case. Remember that the integral shows us the area under a curve. So let's say that area was, for instance, this function, and the area was defined between the x, this is x and this is y, between the value of x equals to 0 and x equal to 1. So this area over here. Well, we can see that the boundaries are actual values for x, meaning that the boundaries have to be now, with the same logic, actual values for u. Hope this makes sense. So if x was equal to 0, right? If x is 0 over here, x is 0, then in terms of u, the u value would be 0 to the power of 2 minus 1, 0 to the power of 2 minus 1, and that's equal to minus 1. So we got one new boundary, and with the same logic we're going to do when x was equal to 1, right, the second boundary, the upper boundary. Well, u instead of that would be equal to 1 to the power of 2 minus 1, so that's 1 square minus 1, and that's equal to 0. Now with that said, we can write our new integral. So we'll do it over here like that. The integral, let me just change colors. The integral will have the boundaries between minus 1 and 0, and instead of all this thing that we had before with x, we're going to substitute with what was it, du, right? This is du divided by e to the power of u. So we have du divided by e to the power of u. Okay, let's write it in a bit of a different way to see what's happening here. In other words, we have the integral between minus 1 and 0. What is du divided by e to the power of u? Well, that's just 1 divided by e to the power of u times du. What is 1 divided by e to the power of u? Well, that's just e to the power of minus u. We're using a power rule over here. E to the power of minus u times du. Okay, with that said, we can solve this, because what we know about the integral of e, the integral of e to the power of x times dx is just e to the power of x plus c. What we have right now is e to the power of minus x. I mean, we have u, but for the sake of the notation, let's just solve the example with x, because it doesn't make any difference. It's still a variable. When we have the integral of e to the power of minus x times dx, what would be the result? Well, we would have pretty much the same thing, but we have to keep in mind that there is a negative sign over here, which we will write as well. So we will have minus e to the power of minus x, so minus e to the power of minus x plus c. Now, let's understand why this happens by reversing it, because remember, the integral is an antiderivative. So if we differentiate this expression, we should go back to the original thing. Let's see if that's true. So if we differentiate e to the power of minus x plus c with respect to x, what do we get? We will have, change colors, we will have minus e to the power of minus x plus c derivative with respect to x. So we will have minus, we keep the minus because that's just minus 1, so that's a constant. The constant stays constant. We have minus 1 times, what is e to the power of minus x derivative? Well, we keep e to the power of minus x, but because the power is an expression of x, right, that's just minus 1 times x, we have to multiply with the derivative of minus x, the derivative of minus x with respect to x. And then the constant derivative is just 0, so that doesn't affect our result. Now, what's going to be the result? We have minus 1 times e to the power of minus x times the derivative of minus x is just the constant, which is again minus 1. Minus 1 times minus 1 is equal to 1. 1 times e to the power of minus x, it's e to the power of minus x. What do we see? We went back to the original thing that we integrated, literally anti-derivative. So yes, it works out. I just wanted to show like where this is coming from. Now, with that said, we're going to apply this power rule of this e number, right? This is an actual number to this case. What's it going to be? Let's see. We will have over here the integral between minus 1. Actually, not the integral. Now we are solving the integral, so we'll have these boundaries between minus 1 and 0, and the result of e to the power of minus u is going to be minus e to the power of minus u. So we have left minus e to the power of minus u. Yes. Now we have a constant there. That's minus 1, right? That's minus 1 times e to the power of minus u. Let's take the constant out. So we will have left minus 1 multiplied with, and in brackets we're left with the boundaries between minus 1 and 0, and over here we have e to the power of minus u. What do we do now? We're going to substitute the boundaries into our variable. So we're left with minus 1 times, and in brackets we're left with the following. We have e to the power of minus 0. Well, that's just e to the power of 0, right? We substituted this one, and then subtract, we substitute the other boundary, the lower boundary, into u as well. So we will have e to the power of minus, right? Write the minus first, and then instead of u we substitute minus 1. So minus 1. Hope this makes sense. And by the way, keep track of this signs, because it's easy to mess up here. What are we left with? Minus 1 times, what's e to the power of 0? Well, that's just 1, minus, what's e to the power of minus 1? Well, minus 1 becomes positive 1, so just e to the power of 1, meaning it's just e. In other words, if we open the brackets, we will have the following. We will have minus 1 times 1, so that becomes minus 1. Minus 1 times minus e becomes positive e, so plus e. And if we write it in a more comfortable way, e minus 1, that would be the answer. And that's it. Hope this makes sense. In the next video we go to part B.